In this video, we are going to be doing problem 22 in chapter 2 of the AP Physics textbook on page 51. So it says a 745i BMW car can brake to a stop in a distance of 121 feet from a speed of 60 miles per hour. To brake to a stop from a speed of 80 miles per hour requires a stopping distance of 211 feet. What is the average braking acceleration for A, 60 miles per hour to rest, B, 80 miles per hour to rest, C, 80 miles per hour to 60 miles per hour? And they want you to express the answers in miles per hour per second and in meters per second squared. So this problem is a bit of a pain in the butt, but we can do it. So for this one, let me zoom out. You just have to kind of visualize what stopping distance is. So basically, let's label that as number 22. So according to Miss Cohen, that's what a BMW looks like. Okay, so from 60 miles per hour, it takes 121 feet to stop. And then from 80 miles per hour, it takes 211 feet to stop. Okay, so we visualized the problem. Now we have to see if there's any unit conversion we need to do. And unfortunately, there's actually a lot of unit conversion we need to do here. So I'm just going to start with the 60 miles per hour. So 60 miles per hour, if you multiply that by that magical number we found in class the other day, you should get 26.82 meters per second. For 80 miles per hour, it's 35.76 meters per second. Okay, now we need to do two things with the distance. So 121 feet, we need to convert to miles because the problem asks us not to find it in miles per feet per second. So 121 feet is the same as, and if you just can divide it by 5,280.02292 miles. And 121 feet, if you divide that by 3.28, you get it in meters. So it's equal to 36.89 meters. Then 211 feet, divide that by 5,280, you get 0.03996 miles. And you get for meters, you divide by 3.28 and you get 64.33 meters. Okay, so we have everything in the units we want now. Now the problem asks us to find the acceleration. So let's write down our knowns and our unknowns. So we know VI is equal to 60 and 26.82 meters per second. We know VF, it's 0. We're going to assume that we start at position 0, so xi equals 0. And then these here are our xf's, depending on whether you want it in feet, miles, or meters. So those are what we have, and we're looking for A. So which kinematic equation do we want to use? Well, we don't want to use number 1 because we don't have time. We're not asked to find time. Again, we don't want to use number 2 for the same reason. It looks like we want to use equation number 3. We have VF, we have VI. We're looking for A, and we have both XF and XI. Okay, so instead of plugging in the variables first, I'm actually going to solve this for A, because we're actually going to have to end up solving for A 6 times. We'll have to do it 3 times to get miles per hour per second, and then for parts A, B, and C, and then in meters per second squared for parts A, B, and C. So and I'm going to get rid of the xi term because we can assume that it's 0. So A is going to be VF squared minus VI squared divided by 2XF. Okay, now we can actually start solving our problem. So part A, we want to do from 60 to 0. And I messed up a little there. The final velocity is 0. The initial velocity is 60. And then we don't want to use the feet here, we want to use the miles. So let me just show you real quick that the units cancel out. So here we have miles squared divided by hours squared. And then here we have miles again. So that cancels out. And then we'll convert this later on. Okay, anyway, now we've got 0 minus 60 squared divided by 2 times this number, and you get negative a big number. So we actually just found miles per hour per hour. So if we just divide this by 3,600, you get it in miles per hour per second. So that ends up being negative 21.8 miles per hour per second. Okay, then, and I'm just going to do the miles per hour per second ones first. Then B, 0 squared minus 80 squared over 2 times, and we want to use this. So when you plug that into your calculator, again, that's in miles per hour. So again, you divide by 3,600, and you get negative 22.24 miles per hour per second. Okay, then part C. Part C asks us how the acceleration when it goes from 80 to 60. So what I did is I subtracted these two stopping distances and said that was the distance it took to go from 80 to 60. Now, I saw other people online do it by taking the average of these two. And one thing I'd like to discuss in class is which way do you think is better. But for now, let's just do it this way. So, let's go back up here. So 211 minus 121 is 90 feet. 90 feet is equal to 0.017 miles, and that's equal to 27.44 meters. So 0.017 is what we're going to be plugging in. All right, so then we do A equals, okay, our final is 60, our initial is 80, and XF is 0.017. So if you plug that all in correctly, and this is in miles per hour, divide that by 3,600, and you get negative 22.81 miles per hour per second. Okay, so that's all in miles per hour per second. Let's do meters per second squared now. So I find that a little bit easier. It's all in consistent units. So meters per second squared, A. So if we're starting at 60, again, we want to do VF squared minus VI squared over 2XF. And we're going from 60 miles per hour to rest, so that's the same as 26.82 meters per second. So we do 0 minus 26.82 squared divided by 2, and we want to use our meters, so 36.89 meters. If you plug that all in correctly, you should get negative 9.75 meters per second squared. Then for part B, So again, it's going to rest, so VF is 0. VI is 80 miles per hour, or 35.76 meters per second. And the stopping distance is 64.33 meters. So if you plug that all in correctly to your calculator, you should get negative 9.94 meters per second squared. Then for part C, our final velocity is 60, our initial is 80, and I almost forgot to do it the meters, sorry, so it should be 26.82 squared minus 35.76 squared. And then again, we're assuming that it's this 90 feet, the difference between their stopping distances. So that would be 27.44 meters that we want to use down here. And if you plug that all in, you should get negative 10.19 meters per second squared. So, I hope you've learned something from that. I know that problem was a bit of a pain in the butt, but I think it's good to explore a little bit of unit conversion.